Hello SGD, Sacred Geometry Decoded. Be a follow-on from some recent uploads, and in the past I have gone into some of the topics I'll be going into now, but as usual it'll be related to systems of measurement, the way things connect together, and whether it's Thoth or Shesed in ancient Egypt, gods of science, maths, weights and measures, whether it's Hermes or Mercury, the same themes carry through with these particular connections, and this will be again measurement and ruler systems and how supposedly ancient units connect, and this harmony, this symphony of coincidence between these and systems of measurement in particularly and especially the concept of geometry as in geo, earth, metre, measure, and sun, earth and moon, but also with the planet. So here's from the symbols of the Rosicrucians. Now there's another, but what we have here is see the light, the dark, well, Lucifer's, but the sun, the moon, and in here the secret symbols of the Rosicrucians in here. So what we're seeing is essentially sun, earth and moon, but this particular geometry, this double vesica, is an important feature. And you could represent it in such a way as well, which brings us to this double vesica, and which brings us to the seed of life. So this geometry is the seed of life geometry, and we can see that in the Osiron, in Sumer, Mycenaean culture, and Greco-Roman, the Golden Temple Sikhs in Amritsar. We also find it in Hindu, Buddhist. It's a constant really across the ancient and modern era, and even this, for instance, you'll see like the Star of David, or that's a hexagram, but also the hexagon. So there's different ways of representing this geometry. The Earth map, where we see the seed of life being brought in there, and by Frankel, but number and geometry, and so it's not just drawing on a piece of paper geometry, because you see the same geometry even reflected in the way that particles organize themselves, and in the basics of because it's just insisted upon that things arrange themselves in these geometric ways because it's the most efficient, important way of doing it. If it was just random, well, whether it's biology, chemistry, basically all the sciences, that they're just born and reside in these geometric constants. So there's the Earth flag, so-called, but this is a I only put this in here because this is a universal truth. This is a universal constant. It's not just Earth. This is so important, really, everywhere. So sun, earth and moon. Now I've drawn that circle around there just to define the longest part of the feet. Now I'll put these links in the description because this geometry is the same as we have here in how to draw a clock, which also leads to then the metrology, and not just the measurement of length, but how the measurement of length applies to timekeeping. Let's see the 30-degree angle now. So a 1 meter pendulum. Now in these videos, for instance, I show it in movement. So, but what happens is that a pendulum at 1 meter swung no more than 30 degrees will create a very accurate second. Also how it applies to other units of measurement and those connections. But so 1, 2, 3. So you can see that video, see it in action. But so 1 meter pendulum swung at no more than 30 degrees. That's not an arbitrary angle. That's been established that if you go over 30 degrees, you start to affect the timing. So if you want a 1 meter pendulum, 30 degrees, just so happens that that would have to be pi over 6 meters, which just happens to be one Egyptian royal cubit. So 1 meter, 1 second, 1 cubit connected. So here's a shot of the chalkboard where I had those pendulums. Now there's some key. So did I say? Okay, so 30 degrees. Now 30 degrees equals 1800 minutes of the compass, or 108,000 seconds of the compass. Now 108 or 108,000, but keep that in mind. Now we come to these pendulums. So 1 meter pendulum, that's pi over 6 meters, or 1 Egyptian royal cubit. we also have this pendulum, which is slightly shorter, but it's 1 second at 45 degrees north or south of the equator. And this pendulum is 3.3 feet. Now 3.3, so 33 feet, those connections, but 3.3 feet is a Saxon yard, as it's called. It's also 3 Babylonian royal feet, or 3 Mohenjo-Daro / Indus civilization feet. Ancient units of measure coming together. Now, also, I'll go into that one for now, but the important part is to note, so the arc of this 1 second pendulum, the Mersenne pendulum, back to the 1600s, that's 27.33 imperial or English fingers. 1 foot is 12 inches or 16 fingers. This arc is 27.33 fingers. Just like with 108, keep 27.3 in mind. And this 3.3 foot Mohenjo-Daro / Babylonian pendulum, well, the straight line across those points is 27.331291 fingers. So once you get to the 4th digit in the finger, you're talking tiny fractions of a millimeter. These are, in all intents, essentially it's the same. So 27.33 fingers. So just like 108, keep 27.33 in mind. This pendulum of 0.994387 meters, that was defined, for instance, Mersenne, also Giovanni Riccioli, back to the 1600s, 1 second at standard gravity, which is 45 degrees north or south of the equator. This measurement almost became the official US standard of measurement, and so just like Talleyrand proposed in 1790 that the metre be set at a 1 second pendulum at 45 degrees north, this very well nearly became the official metre, and it nearly became the official US yard. So that would have been 3 feet, or 1 US yard almost became this particular measurement. Now, 1 metre pendulum, that arc is pi over 6 meters on an Egyptian raw cubit. Cubit is from the elbow to the tip of your finger. Egyptian raw cubit was divided into 7 palms. Each palm was divided into 4 fingers. So an Egyptian raw cubit is also 7 Egyptian palm, or 28 fingers. That's relevant because the, again, I'm not sure of the exact pronunciation, but the jezza, which is sometimes referred to as the Egyptian foot, well, it's actually the Egyptian forearm because it's 16 fingers, which is 4 palm, or from the wrist to the elbow. Brings us to the concept of Vitruvian Man. Now, in Vitruvian Man, we see that the foot there it's exactly the same length from the wrist to the elbow, which is the same distance from the bottom of your neck to the top of your hairline. And so a foot is the forearm. Is also described by Vitruvian Man, which is based on an ancient Roman text which refers to that they were studying older temples on the symmetry proportions of temples. So 1 Egyptian foot, or 1, 2, 3, 4, so that's 16 fingers, equals 0.299199 meters. 1 so-called modern English foot equals 0.3048 meters. 1 English foot is 16 fingers. 1 Egyptian forearm, same thing, is 16 fingers. So they're both 16 fingers, and they have a tiny margin of error between them. That difference is 5.6 millimeters. So the difference between the Egyptian foot and the English foot is 5.6 millimeters. And if you take 1 metre and subtract 5.6 millimeters from it, you get the Mersenne pendulum, which creates an arc of 27.3 fingers, which brings us back to that Mohenjo-Daro one, but just as with 108, keep 27.3 in mind. Brings us back to the sun and the moon. I can just skip through because it's just showing the geometry to arrive at the Maltese cross and then the Templar cross, but geometry, sun, earth, moon, and planetary measures as well. And so now imperial versus metric. So when we think imperial, we usually go to inches, feet, maybe yards, but the imperial measurement system is broken down in different ways, and so it's important to think about them. So as we did with the pendulum, we create the vesica, which makes the seat of life, which gives us the geometry to make a very accurate pendulum of 30 degrees based on 1 meter. That's the same. From this geometry, I could just add the circles and do the geometry, set it at 1 meter. I get that pendulum. But now we compare the yard, or 3 feet, or 36 inches, to the meter. Back to Vitruvian man, so we see the concept of a cubit. The height of the man is equal to fingertip to fingertip. That's by definition an idealized man should be 4 cubits high, 4 cubits wide. You have an axis of symmetry, so the axis, so 2 cubits creates an axis of symmetry, and that would make, so half of a man's height or half of a man's fingertip to fingertip is 1 yard or 1 fathom. You might have heard of a fathom, especially sailors would say we're measuring fathoms. That is 6 feet, the height. So 1 fathom is the height of a man, idealized man. Even the term fathom is still in our vernacular. For instance, my thoughts are stars. I cannot fathom into constellations. So when we, if you cannot, to fathom something usually is to understand it, or to, literally it's a measurement, but also to fathom something is similar to get it to the bottom of it. I can't fathom why he doesn't go along with us. These metrological terms are also, now for instance, yardstick. Now, I have 1 yardstick by which I test every major problem, or that, yardstick is usually, again, it's an expression used to say, to understand something, or how you would measure something. My yardstick of knowing if someone is, honest or dishonest is this or that. My yardstick of whether this is a good or a bad deal is this or that. So fathom, yardstick, these terms have left their presence in our language. Now, 1 yard, it's important to note, so usually yards we think feet or inches, but so 1 yard is half a fathom, or 2 cubits. This is by the imperial English system, and for instance ancient Babylonian, their cubit was 1.5 feet, which is different from the English cubit, which is 4/7 forearm or feet. So 1 yard is 2 cubits equals 3 feet equals 4 span. Span is from your outstretched fingers, from the tip of your thumb to your pinky. 1 span is also from your chin to the top of your skull. There are also hands, so 1 yard is also 12 palm, or 36 inches, or 48 fingers, digits, or 108 barleycorn or grains, or 432 lines, which is a poppy seed. So 1 inch, or the thumb, 12 inches per foot, or 36 per yard. And also the rule of thumb is another one of these terms that have been embedded in our language. Grains or barleycorn, so 1 inch is 3 barleycorns. This was one of the oldest definitions of it. Even grain of truth would be another expression that's come in. And so if 1 inch is 3 barleycorn, then 4 lines is 4 poppy seeds or lines. So 4 poppy seeds equals 1 barleycorn. Therefore 12 lines or 12 poppy seeds equals 1 inch. Back in the day, this was how they were defined as well. So the yard, the meter, and sun, earth and moon, but also the planets. And we'll look at that now, and things hidden in plain sight. So again, that double vesica, 1 meter, that would be 1 meter from there to there. I think I've got that. Okay, 1 meter equals 1.09 etc. yards. And I've also got these breakdowns in different, we'll come to those in a moment. But to start with, I already mentioned 27.3, so 50 centimeters or half a meter is 0.2734 fathom. 25 centimeters is 0.2734, same number but in yards. So this double vesica, as we saw, linked to great lovely pendulums linking ancient units of measure. So all of these that I have here are what you call modern English imperial, with the exception of ionic fingers. Now it just so happens that the ionic scale is an ancient unit used at least in ancient Greece. I would say even earlier connections, but you'll notice that 50 centimeters, or 0.2734, exactly the same number, just to shift the decimal place, that appears again. Now I'll bring back as a reminder the pendulum and how 27.33 English fingers is, well, essentially 1 Samian cubit. Again, it's 1.009 Samian. Now Samian, or Samos, as with the Ionic and the Doric scale, as well as a so-called modern English scale, to be found in the Salamis stone in ancient Greece, and can be applied to the Parthenon as well. But that's one connect. But 27.3 Samian scale, just like with the Ionic scale appearing, and again fingers. It's much better to think about feet or yards in fingers when it comes to applying to. Inches are nice, but fingers is actually where I think it's at. But also the pendulum and the metre, as we saw, connected to the second, to the Egyptian royal cubit, the margin of error between an Egyptian forearm or foot being 5.6 mil, which is exactly the difference between the Mersenne pendulum at 45 degrees north or south of the equator. These margins of error containing information. So what we have there, now I'm just going to focus on those for now. So essentially that's 0.273 is 27.3% of a yard. Also would happen that section is an Egyptian raw cubit, just as we saw, same thing happening with the pendulum. So now I'll just simplify it and we'll be using yards. So each 25 centimeters is 27.34% of 1 yard. But now we'll apply the yard, or 3 feet, 36 inches, or etc. We'll use that. So if the yard is our yardstick, that's the Earth, and the Moon is 27.3% the size of the Earth. Recent upload, I'll put the link in the description, and I'll show you anyway. Here we see the relative size of the Earth and the Moon. Now, for instance, the Great Pyramid, if the half base is 1, then the height is 1.273, give or take a fraction, using the survey data. Each site has a slight variation, so whether it's the J.H. Cole or the Petrie survey, there we see we're getting that 1.27, so 1 plus 27.3%. So again, we can see there the averages of the Petrie and the J.H. Cole survey, 1.2728. Just round that up to 1.273 or 1.273. So if the Earth, again, just like with the yardstick, if the Earth is 1, then the Moon is 27.3% the size of it. And more than that, the barycenter, or the point at which the Moon orbits the Earth, it's not at the core of the Earth, it's 27.3% below the surface. So there's another connection. Now you could apply this yard and metre to that. I just haven't made the image because it's exactly the same thing. And now planets. So an AU in Bode's law, the distance from, in this lovely geometry, which predicted planets which hadn't been, including the asteroid belt, which hadn't been yet found, would make distance from Sun to the Earth 1, and that's also called an AU, or an astronomical unit. So now we'll be using that as the yardstick. Just so happens that if from the Sun to the Earth is 1, well, the orbit of Venus is 27.3% closer, and because of the elliptical orbits there, we see the variation, but we see that it falls within that, so it does pass through that point. And we've already mentioned that 1 inch is 3 grains, so interesting to note that 1 yard is 108 grains. 108 million kilometers would pass through that point. Why I bring that up, because 108 another beautiful number. Now, also in measurement, so whether it's the Saturn or the Sun, but just in proportion, and also so 30 degrees of a pendulum was 108,000 seconds of a compass. That's the orbital speed of the Earth at its top speed. By definition, the circumference, equatorial circumference of the Earth is 21,600 nautical miles. That's how they define a nautical mile. So therefore, the maximum visible, or the half, would be 10,800. But now the diameter of the Earth times 108 gives you the diameter of the Sun. The diameter of the Sun times 108 gives you the distance from the Sun to the Earth. The diameter of the Moon times 108 gives you the distance from the Moon to the Earth. And the diameter of the Sun times 1080 gives you the distance from the Sun to Saturn. This will be, so if the Earth is 1 AU, the distance to Saturn is 10 AU, and it just so happens that the polar diameter of Saturn, within a slight margin, again exact measurements because it's well, it's a gas planet, so defining the exact surface of it, but very, very close, within, again, acceptable margins. The polar diameter of Saturn is equal to the orbital speed of the Earth per hour, and again, slight variations each year, elliptical nature of things, but 1 year on Saturn is 10,800 Earth days. So that's these nice, again, back to the pendulum, we see these same numbers reappearing. Already saw 27.3, and, well, Earth, Venus, and the Sun, and the next one, closest planet to that, is Mercury, which again is 27.3% of 1 AU closer to the Sun than is Venus. So just 27.3% of Earth's orbit, Earth's orbit minus 27.3% gives you Venus's orbit. Venus's orbit minus 27.3% gives you the orbit of Mercury. And again, because of the elliptical sort of nature of orbits, it will fall through that point. One or two previous upload to this, I went into the geometry of a pyramid and how this also gives you that same thing that's happening. So the proportions of the pyramid are also reflected in the metrology of yards, meters, which would link us also to seconds, to the Egyptian raw cubit. The difference between different pendulums, well, the difference between the Egyptian foot and the English foot, or 16 fingers, is the difference between the Mersenne pendulum and the modern definition of the metre, which gives us a 1 second pendulum, which gives an Egyptian raw cubit. Interesting just to think, even so when they measure light speed, for instance, it's meters per second. Nice connections will actually emerge from there, but I want to do an updated version in regards to that. And so what we have is well, a lovely symphony of coincidences built from some very beautiful geometry which has been passed down through time. But I've been focusing on the pyramid, but these geometries, these proportions, these units of measurement actually link across multiple cultures which have apparently no connection to one another. Now, for instance, in ancient Old Kingdom Egypt, 27.3 grams was a unit of weight. In the Indus civilization, 27.3 grams was a unit of weight. 27.3 grams was a Greek ounce. 27.3 grams was the Roman ounce. And what we just, yes, at the very least, it's a nice way to memorize things, but the implications could be much more than that. I tend not to go into those things. I prefer to leave it to people to make their own analysis in regards to that. But for those sort of strict materialists who, well, no, here it is, so at the very least, why isn't this taught as a system of memorizing and educating people in that sense, as opposed to the standard education sort of system? Well, why not make of it what you will in terms of the deeper implications, but I would just say, well, why is this some, basic systems, some inherent numbers, 27.3%, 108, how they connect to units of angles, time, also connections between the allegedly modern metric system and how it connects to these ancient systems in very powerful ways, and also links to ancient systems. Again, we've said it sort of before. Now, what's the metric for coincidence? Okay, or maybe, but also, so the full moon or the synodic month takes 29.53 days per full moon. Well, 25.53, 29.53, and a lunar year, which is 12 times 29.53 is 354 days. So again, these units just so happen to correspond with one another. And so whether it's sun, so Earth and the moon, not just in relative size, but also the orbital relationship, for instance, the barycenter. Now, at its maximum, the distance from the Earth to the moon is, in AU, 0.00273 AU. So again, just shifting the decimal place would also give you the, in AU, as we mentioned, in regards to, well, AU, it's just, what can you, yardsticks, you got to fathom, what's the yardstick, how do you fathom this, a grain of truth, and measuring, and the implications, whether in a secular sense or in a more spiritual element, it's pointing to something, and more and more resistance is breaking down as they start. Well, again, you can measure these things; they're tested. You can just say coincidence. Well, more power to you if you want to believe that. But well, that same level of coincidence could then be said of bona fide acceptable theories. Well, at some point, like you build up enough coincidences that it becomes an acceptable hardcore theory. You don't say it's coincidence that the sun rises in the east every morning. It's clearly a pattern, and if these patterns are repeated often enough, reason just dictates, it's accepted that, well, this is what's happening. It's not only explains the past, but it also predicts what's going to happen. And so sun, earth, moon, planets, ancient metrology, timekeeping. If you measure length, you can measure time, and it just so happens to be built into focus on the Great Pyramid, but again, you'll find it as essentially a standard in ancient architecture, as well as a standard in modern architecture, major public buildings, major cathedrals, basilicas, not just some random building somewhere, but highly architectural. Parliament House, for instance, here in Canberra, St Paul's Cathedral, London, US Capitol building, major cathedrals, public buildings have these. These are not just randomly designed. There's high amounts of design go into these things, and it's always there, and it has been in the past, and not just in the architecture, but also in the systems of measurement and the systems of weight, and it's just a constant. So at the very least, it's a way of memorizing things, and at the more deeper level, it's thought-provoking in that, well, how can all these come together? How can it have been part of our ancient traditions? It's our birthright in that sense, and it's still embedded with us today. But Brian Cox's, for instance, Neil deGrasse Tyson, no, they do this is verboten. Do not discuss these things. They just insist it's all random. It's all a coincidence. There's nothing to this. If it's not a long string of decimals that it's impossible to remember, then it's not sciencey enough. Well, weights of measure, what can be more materialist, rationalist science than that? And, well, implications are deep.